I suppose by now you all know that we're going to have our lectures posted online with the explanation recorded. The lecture that we were talking about, the last lecture we were discussing in class was about variables. Uh, we started this lecture, however, we haven't had the chance to continue it to the end. What I will do is that I'm going to review it for you, and continue it to the end. So variables. Uh, by now, most of you are familiar with what variables are. So a variable, the formal definition of variables is found here. We said that the variable is actually a memory location that has a name. And we said we're going to use this name every time we refer to that memory location. However, this memory location or this name actually stands for a certain address, which you don't have to worry about. So to refer to the variable, we refer to it by the variable name. Now, why would we want to refer to a variable? Because we want to store data in this variable. So we store data in memory locations and we use this data. We do some computations on it, as we shall see in a minute. We can add, subtract, multiply, divide, do any operation on this variable, on the data and the variable, and then we can actually store the result in the same variable or in another variable. So variables are basically used in order to be able to do computations. Without variables, the CPU cannot do computations. So we need variables to put the data, to hold the data in them and do computations on these data. So whenever in your program you want to do some computations, you actually need a variable. How do I get a variable in my program? I have to declare this variable. We have discussed this as well. What do you need to do to declare the variable? You have to have in mind what kind of data you need to put in the variable. If the data you want to put is integer, then you would have an integer data type. For example, in this example, you have int standing for integer data type and the variable name. So you have to give the variable a name. In this case, the name of the variable is my integer. So we call the first line that you see here, this line is called variable declaration. Following declaration, you can initialize the variable. The word initialize means that you give it an initial value. Saying that, you can give it an initial value, which means that you can actually change this value. Okay, so a variable, the name variable varying refers to the fact that even if you give it a value, or you have to give it a value, but this value can be actually changed throughout the program. And we said that you can do it in one line. Let's say integer, my integer is equal to 5. And in this case, we have actually declared the variable my integer as an integer. And we actually have initialized it to 5 as well. We can initialize it to 0, to 100, to whatever number you want, but it has to be an integer. And let's recall what we said in class. Integers are data that can have negative and positive values, but without a decimal point. This is an example which we have also discussed. In this example, we have two variables, my integer and my float. My integer is an integer, is defined as integer. We declared it as int, which means integer, which means that I'm expecting only numbers that are positive or negative and that don't have a decimal point. My float is a variable. I can name it any name. We will see the rules of naming in a minute. And this is a float. Okay, so float, which refers to the data that I can store in this variable, is actually floating point, which means that I can have positive and negative of numbers that have a decimal point or no decimal point. So that are the floating point numbers. An example of a floating point is 7.8. One would ask me, Can I have it 7? Yes, but it will be stored as 7.000 as we have seen in the example in class. This is an example of printf, which I also suppose I explained this for all the sections. When I say my integer here, would it refer to my integer here? Does this my integer here, is it the same as my integer here? I expect that most of you thought no. Yes, then that's true. The answer is no. My integer here is just the ASCII. My integer, as we said in class, as if you are writing in text. This doesn't refer to the variable. However, the only meaningful thing here is the percentage. So whenever you have percentage, this is for the format specifier. So whenever you have a percentage, the compiler will look at the letter beside it. If it said D, this tells the compiler that I am followed this string of characters. How do we know that this is a string of characters? The quotation marks, the double quotes. So the string of characters is enclosed in double quotes. Person D, okay, tells the compiler that after the string of characters, there's a comma and there's an integer value. And I need you to put this in the place of person D. And that's what we have discussed. So the compiler will actually print my integer equal, this is just the ASCII string of characters. It will replace person D by the integer here. It happened that the integer here is a variable. It could have been a number. I could have written here 100. That would be possible too. The most important thing that person D is telling the compiler that the string of character, this is the string of character, is followed by a comma and an integer. And in this case, the integer is my integer, which is stored in memory as 5. So the output would be my integer equal, and this person D is replaced by my integer, in this case, replaced by 5. My float equal, all of these have no meaning. This is just the ASCII representation. This is a string of character. The only meaningful thing here is %f. So %f is going to be replaced by the float that's followed by a comma. So %f is telling the compiler that after the string of characters, there's a comma and there's a float. This float here, I could have written 0.5, 7.6, whatever float I want. It happened here that this float is actually a variable and it's called my float. So the compiler will get the value from my float, which is somewhere in memory, and what it has stored in it is 7.8. So %f is going to be replaced by 7.8. And the output would be my float is 7.8. This is called format specifications. When printf encounters a format specification, it converts the value of the variable after the text and outputs it accordingly. Okay, so it has to have it when it sees person D, it will actually print it as an integer. Okay. The following table describes some format specifiers. We discussed this as well. So %C is a character, %D signed integer, %F float. So that's what we saw, %D for the integer, %F for a float, %C for a character. We discussed this in class, characters. We will have another session on characters as well. %S as a string of character, %U as an unsigned integer, so that if you give it a negative value, unsigned is always positive. So if I give it a negative value, it will be replaced always with a positive one. So this is format specification. You're specifying that it's an unsigned integer, which means it doesn't have a sign. That's the absolute value of the number. % prints actually a % sign. That's it about this table. Can we change the values of variables? We said yes, we can, and we have done it before. Yeah, so x equal 3, y equal 5.14, x equals 7, and we said this equal is not the equal that you know in mathematics. This equal is actually called the assignment operator. It assigns the value to its that's on its right hand side to the variables on it to the variable on its left hand side. So the assignment operator always has variable on the left hand side. It's not possible, we said, it's not possible to have 7 equal x. It has to be x equals 7. So 7 is going to be put in x or assigned to x. Y equal y minus 1. I said that if you see this, you would think that this is impossible because this is impossible in mathematics. However, it's possible. It's possible in programming, as we said. We said this is going to be hidden. Okay, what we finish first is the right hand side. We get the value of y, in this case 5.14, minus 1, we'll be left with 4.14. Yeah, that's what we discussed. So let me try this here. So 4.14 and 4.14. I guess this is not much of a good handwriting. So 4.14 شو بنعمل فيها? What do we do with 4.14? 4.14 is going to be actually assigned to y. And this is the point that us as programmers, we need to actually learn that the left-hand side is the last step in the assignment equation, in the assignment statement, excuse me. So y minus 1 happens first. You get the value 4.14. A very important note, I said at this point, before it's assigned to y is still 5.14 until I assign it to y using the assignment operator. So now y equal 4.14, so I'm putting 4.14 in y. Okay, so these are the new values of x and y. One important thing also that I mentioned is that the variable can hold only one single variable, one single value, which is the last value you give it to it. So the last value that was given to x is 7. The last value that was given to y is 4.14. What happened to the previous values? They disappear, okay? They don't exist anymore. We said there are rules for selecting a valid identifier or a variable name. It must begin with an alphabet, character, or an underscore. I also discussed this, I suppose, in class. So it always starts with an alphabet or an underscore. So if you see a variable that starts with a digit, then it's not a valid variable name, which means it will trigger an error. It will trigger an error. It may contain only letters, digits, and underscore. So what can the name has? Letters, okay, digits, and underscore. No special characters are allowed, so you cannot have this in the variable name. It's case sensitive, which means that if you put a capital letter in it, when you refer to it again, you also have to put a capital letter. And you cannot use C keyword identifiers, middle integer, if, case, while. You don't have to know all of these, but these are reserved words. So it goes without saying that these words, you cannot use them as your own variable names. In the exam, you might be asked to identify which of these names is a valid identifier. You can see that the first one is a valid identifier. The second one is a valid identifier. No, is the second one a valid identifier? So this is okay. So distance is okay. Rate percentage is not okay because it has a percentage. Initial time is okay because underscores are allowed. 1x is not okay because it's starting with a number, with a digit, I mean. X underscore sum is okay because underscores are allowed. Distance is okay, but you have to pay attention. Every time you have to use them, you should actually put a capital letter. You have to put the uppercase letters the way they are. Okay. X underscore 1 is also yes. Yes. Switch is a no because it's a reserved word. X and Y is not allowed because and percent is not allowed. The operations that you can do in C are addition, subtraction, multiplication, division, and modulus. We have discussed those, all of those. I think I have discussed modulus with you. If I haven't, then I will discuss it. I discussed it with one of the sections. I wonder if I have discussed it with other sections. Let me see if there's a way. Okay, so maybe we have to use the pen. Okay, let's stay with the pen. So we said, what is modulus? Modulus is the remainder after division. Let me just give you a hint of how to use it before I continue. So let's say 16 modulus. Okay, so 16 modulus 5. So what we do is that we divide 16 by 5. What would be the result? The quotient is 3. The quotient is 3. And I think that's funny handwriting. The quotient is 3. And the remainder is, what's the remainder, guys? The remainder is 1. So if you divide 16 by 5, the quotient is 3 and the remainder is 1. Well, 16 modulus 5 is then equal to 1. So modulus is the remainder after division. So modulus is the remainder after division. This is modulus, modulus operator. This is the modulus operator, the remainder after division. A trick, which is the following. Let's say 3 modulus. I have to get a pen for this because I'm using my finger. It's not working very well. So 3 modulus 5, what do you think that would give me? This is the trick. If the number is less than this number, and by the way, modulus, you should always have integers, no decimal point, okay? So 3 modulus 5 is always the number itself, okay? So if the number is less than the dividend is less than the divisor, then it's always the remainder is going to always be this number. لأنه 3 divided by 5 is 0, remainder 3. So if you have a number, modulus another number, okay, where the dividend is less than أصغر divisor, then this is the modulus immediately. So 3 modulus 5, because it's less than 5, it's immediately 3. 16 modulus 5, it's greater than 5, so 16 divided by 5 is 3, remainder is 1. All right, if somebody still doesn't understand it, you can send me an email. So what do we do here? What do we have here? We have two variables, number 1 and number 2. Number 1 and number 2 are, number 1 is equal to 5, number 2 is equal to 6. So integer r, look here, we have actually declared r to be an integer, and we immediately gave it, rather than an initialization, we actually gave it immediately an expression, which is number 1 plus number 2, which is an arithmetic expression. We are adding number 1 plus number 2. So what would the compiler do? As we learned in class, we cover r, yeah, so you cover r, you don't look at this part, you start here, we start here, number 1 plus number 2. So number 1, how would the compiler work? It will go to the memory location where number 1 is, which is what? You will have 5 there, so it will do 5 plus 6, that's 11. Now the result, which is 11, is assigned to r. So the result of number 1 plus number 2 is assigned to r. The sum is therefore %d \n. %d is replaced by whatever is after the string of characters as we discussed. Okay, so comma r is going to be put instead of %d. In this case, what do we have in r? We have 11. All right. Okay. So this is another discussion and explanation of when we have x equal x plus 1. What you do to execute it, first you get x plus 1. Okay, so how would the compiler work? X is substituted by its value from memory, which is 4, plus 1, that's 5. And now 5 is assigned to x. And I told you this is the difference between mathematics and programming. Okay, the equal here is an assignment operator. X plus 1 is done first. 4 plus 1. The result is put in x, and now x will have the value of 5. Is this clear? Division, how is the division done? Okay, so integer a is equal to 5 divided by 3. A will have the value of 1. Okay, why will it be equal to 1? Because it's defined to be an integer. I think one of the sections, I believe, not both we haven't discussed this in both sections. I have discussed this with one or two sections. So integer a, we said that integer a, we have an assignment operator. Okay, the last step is looking at integer a. I used to cover this with the eraser, as you remember. So integer a is covered. We don't look at it. The compiler will start with here. It has 5 divided by 3. 5 is an integer and 3 is an integer. So it will do an integer division, which means there is no place for a decimal point. So it will do 5 divided by 3. So 5 divided by 3 is 1 point something. But since it's an integer, it will only keep the 1. So integer a is equal to, integer a is given the value 1. So why was the value 1 given to a? Because both sides are integers. There is no place the compiler will perform integer division. There is no place for a decimal point. Same case here. So 3 divided by 6. So the compiler will start with the right hand side with 3 divided by 6. It sees an integer here and an integer there. So it will perform an integer division. 3 divided by 6 is 0 point something, 0 0.5. But because we are doing integer division, there's no way that we cannot store the 0.5. So the answer is 0. 0 on the right hand side is given to b. So b now has the value 0. To have floating point results, okay, in order to keep the decimal point, you have to have at least one of either the dividend or the divisor should be a float, okay? So in order to have the result with a floating point, to have floating point division, one of the operands, that is the dividend or the divisor, has to be a decimal, or what we call a floating point. So 5.0 divided by 3, now it's going to be 1.666, and the value is put in a, which is, it has to be a float. If it was an integer, we said, it will only keep the 1. It cannot, if a was an integer, even if I give it a floating point number and it was an integer, if it wasn't a float, you cannot save all this number. It will only keep the integer part. Luckily, a is a float in here. It's declared to be a float, so it will keep 1.666. Or you can have both operands floats, in this case, of course, as well. The same thing as here. The answer is a float, and in this case, it's 0.5, and it's given to b. Since b is a float, so b will have 0.5. If b was an integer, it can only store 0. Luckily, b is a float. Okay, so I would advise you to pause here and try these operations to find the results. Yeah, so the result of D is going to be, I assume you have paused and tried this. So D was going to be 5.0 modulus A. 5 modulus 2 is actually, yeah, exactly, it's actually 1. Yes, so 5 modulus 2 is 1. D is equal to C divided by A. C is 7, A is 2, so 7 divided by 2. Remember, they're all integers. So 7 divided by 2 is going to be, yes, you said it, 3. No place for a decimal point, no floating point division, because both sides, both operands are integers. W is equal to Z divided by X. Z is 7.0, X is 5. Okay, and they're declared as floats. So 7 divided by 5. Okay, that's 0.24, I suppose. Okay, so can we store the decimal point? Yes. A equal A plus 1. Okay, you just increment A by 1, which will become 3. Now, let me have a break here so that the recording wouldn't be long, and we'll start with operators precedence.